Yeah, all right. So we're doing a little review of what we talked about on Tuesday. And Kat shared that she remembers learning about the interquartile range. And so if we have our data, we could break it up into quarters. And to break a line of data up into quarters, we draw 3 lines. Because if you have like a line of data from here to here, and you draw 3 lines, you get quarters. My quarters aren't equal whatever, right? So there are quarters. We have quarter 1, we have quarter 2, we have quarter 3, we have quarter 4. Just like a dollar, you break it up into quarters, you get 4 quarters. And this is called Q1. This is called Q2. This is also the median. And this is called Q3, right? And the interquartile range is Q3 minus Q1. So it's like, hey, here's the stuff in the middle part. What else did you learn on Tuesday? What stands out to you?
We also learned about how to find range.
Okay, find range. What is the range?
Range is the maximum value and the minimum value subtracting each other. That's how you find
Okay, perfect. Yeah, so maximum value minus the minimum value, that's your range. That's great. Do we learn about any stuff that starts with M? 3 things that start with M that are measures? Yeah, so the mean, the median, and the mode. And which one is the middle data? The median, right? And if you have 5 numbers, so if we have 40, 42, 57, and 84, and 92, right? These are our numbers. What is my median? 57, right? 57 is my median. What do you want to do before you figure out your median? I made this mistake on Tuesday. Yeah, put them in order, right? Otherwise, you're just randomly choosing whichever one's in the middle, and you're saying, that's my median. No, actually, that's your biggest number. Just happened to be in the middle because you didn't sort it. All right? And then what do we do if we have even number of, so we have 1, 2, 3, 4, 5, 6. What's my median?
2 middle numbers.
Okay, it's going to be the 2 middle numbers.
Add
them together. So 99.
Divided by.
Is that right? That's 99. Let's just make this one 43. Oop. Now it's 100. Divided by 2 is what? 50. So my median's now 50. Okay. And then what would my mode be if I had these numbers? What's my mode? What is mode? Anybody heard of the band Depeche Mode? Nobody's heard of Depeche Mode? If you've heard of Depeche Mode, say aye. Nobody's heard of Depeche Mode. Now I know I'm old.
Mode is the value that occurs the most often.
Yeah, mode's the value that occurs the most often. Anybody heard of like, what's like the fashion phrase mode? I can't remember in French. Mode means something in French, like fashion, current fashion, most popular, most occurring fashion. So mode is the most occurring number. So in my numbers up here, what's my mode? 92, because it occurs twice. Okay, and now what would my mode be if I had these numbers? What is it? 92 and 3, and we call that bimodal. And now what would it be if I had these numbers? So they're no longer sequentially. Now it's multimodal. It would be 40, it'd be 3, it'd be 92. And then if I happen to have another 3, now it goes back to just my mode is 3 because it's the most commonly occurring number. Okay? And then to get the mean, I add them all up and I divide by the total number. Right? And so mean, median, mode, range, interquartile range, the 5-number summary, which is your minimum number, your maximum number, and then your Q1, Q2, Q3. I think that's the 5-number summary. Is that right? Chat. What is a 5-number summary in statistics? Make sure I got it right. Minimum, maximum, first, second, third. That's your 5. Yeah, same thing. Median and Q2. That's your 5-number summary. So mean, median, mode are measures of central tendency, measures of center. And then we talked about the IQR, and we talked about the range. Those are measures of spread, how spread is my data. 5-number summary kind of gives us a measure of spread, minimum to maximum. How are my numbers distributed or spread out? And then we also learned about standard deviation, variance and standard deviation. So let's do this. I want you all to, for these numbers here, calculate the mean. Okay, so they're right there. Calculate the mean. The numbers are 3, 40, 3, 3, 40, 43, 57, 84, 92, 92. So for those numbers right there, calculate the mean. Do it. I wonder if people can see them in this video. Can you see those numbers there? Yeah, I think you can see them all right, except my head's in the way. Now you can see them better. Calculate the mean. Okay, so now we're going to calculate the mean. To do this, I'm going to use a spreadsheet. I am Iron Man. What are the numbers? They're 3, they're 3, they're 3. What's the next number?
40.
So I've got 3, 3, 3, 40, 40, 40, 40, 40, 40, and then 43, 57, 84, 43, 57, 80, 84, what? 92, 92. Okay. So I'm going to add them all and then divide by 10, right? Or I could just do this. Average. Boop. It's 45.7, okay? And I'm going to insert, let me go a little bigger. Why can't I go bigger? Where is it? Temp. Why can't I make this bigger, man? I don't have my little make it bigger right there. I don't know why that is. Let me refresh. Now it's there. Okay. I'm going to insert a row up here. Now, how do I calculate standard deviation? Anybody remember that formula? Wow, you guys just all doing other stuff. It's just me and Kat here talking this morning. So the standard deviation formula is going to be, let me make sure you can see this on the screen. It's going to be whatever data point, so xi minus the mean, and then we're going to square that to get rid of the negatives, and we're going to sum it up. Okay, I made a weird sigma. That's what your sigma should look like. Then we're going to sum it up. All right? Standard deviation. So I need to first do this xi minus x bar. Okay? So it's going to be this one minus that one, and I'm going to hold that constant. Does that make sense to you? Say I if that makes sense to you. Say no I if it doesn't make sense to you. Good. And then it says, do you want to fill these all the way in? I say, sure. All right? And so there's the differences. And then if I sum that up, what interesting thing is going to happen if I sum up these numbers, just out of curiosity? What are they going to sum up to? 0, right? Because the mean is kind of like what's in the middle. It's the balancing point. It's the number where numbers on the left and right equally balance. So if you take all the numbers and subtract the mean, right, you'll get all these, and they zero out because it's the balance point. So I've got each of those, and now I'm going to square that. So I'm just going to come over here and do this, right? Just kind of like that's me just saying what that operation is. And to square it, I could say equals this times this, right? And then fill it in, sure. And now when I add these up, I get that. So what's the last part of getting the standard deviation? We got this part. We've done that. We have to divide by n minus 1. Okay, why minus 1? Just makes things more accurate with a sample for whatever reason. Okay. Do you have to understand why when you put a car into drive, do you have to understand exactly what's occurring under the hood? No. You just put it in drive. When you push the accelerator, you push the brake, do you have to understand what's actually occurring in, engineering under the hood? No, you just push the accelerator, you push the brake. When you divide by n minus 1, do you have to totally understand why that's what you do? No. It's just what you need to do to make a sample more accurate. That's all you got to understand about it. I've never understood it. Okay, n minus 1, that's fine. There's a lot that we don't understand that we do every day. I don't understand how a toaster works. Like, I kind of get it. Like, electricity somehow makes heat. But if civilization ended and there's no internet or AI, and I was like alone, I wouldn't be able to create a toaster. But I use it. Now we're going to divide by n minus 1, and that will give us our standard deviation. So our standard deviation is going to be equal to this, divided by n minus 1. What's 10 minus 1? 9. There we go, standard deviation. And then what is my variance? Sorry, that's my variance. What's my standard deviation? I'm confused. Hold on. Variance is this. Standard deviation is the square root. So I was getting it right. Standard deviation is going to be equal to the square root of that. Okay, so on average, a point will deviate from the mean 35.63 with these numbers. Anybody have any questions or comments, contributions? How many people watch that and you're like, okay, good. It's making sense to me. And we have a measure of center and we have a measure of spread. So if you think about our supplier A and supplier B, right? Same part, same price, same average delivery time, but one will get it to you in 9, 10, or 11 days. The other gets it to you in 2, 10, or 18 days. Very different spread in delivery time. So you want to know the center, the average, how long they take to get it to you, but you also want to know the spread. So if we had supplier A, supplier B, and supplier A gets it to us in 9, 10, or 11 days, and supplier B gets it to us in 2, 10, or 18 days, the average, the mean, is 10 and 10 for each of them, right? And then our variance and standard deviation variance our variance is 1, standard deviation 64, and equals square root of our variance gives us our standard deviation, right? So the averages are the same, but the standard deviation is 8. What's the difference between 2 and 10? What's the difference between 18 and 10? Right? So the standard amount that a point deviates from the mean is 8. What's the difference between 9 and 10? What's the difference between 10 and 11? So the standard amount that a point deviates from the mean is 1. So when you look at like, okay, what's the average and what's the standard deviation, you could say, all right, well, let's go with the people. The average is the same, the price is the same, the part's the same, the quality is the same, but the delivery times have greater variance. This has greater variance, deviates on average a standard amount, 8. This has less variance, deviates a standard amount of 1, standard deviation. How many people that is like, oh, okay, that makes more sense? Say aye. Okay, that's what standard deviation shows you. All right, cool.